Okay, and so this was the slides we were on, and we were talking about the plan for next 6 weeks. So we're currently in week 19. We'll do a introduction to the visual analytics, what it means, how is it different, and from just pure data validation, and then talk a little bit about the workflow design. So essentially, when you do the analysis, it involves a few different steps, and that's what the workflow is. And then the next 4 weeks is covering different type of data analysis. That's quite common. And so the first one is data preprocessing. So this is the part where you need to kind of clean data, maybe reformatting or converting the data. So that's the data preprocessing. And the week after, which is the third week, and it's about descriptive data summarization and distance measures. And so this is more about the different statistics about the data. So start with the simple ones. For example, what are the mean, minimum, maximum? And we're going to talk about the quantiles. And then, then these are the simpler ones. And then we're going to talk about more complex ones later as well. And also we're going to talk a little bit about distance and measures. How do you measure distance? And we all know how do we measure usually using Euclidean distance. There are different distance measures. Okay. And then the next 2 weeks and the week 22 and 23, and we're going to talk about more kind of advanced analysis. And so week 22 about predictive analysis, and this is actually much more related to machine learning. So we're going to talk about classification and regression. So you might have some of these covered in the different modules. At least you would know the concept. And so some of these you might be familiar with them already. But we'll start from the beginning and discussing what is classification, what is regression, and how to disease in the tools we mentioned, the 9. And then after that, we're going to do other type of analysis, which is clustering, outline analysis, and association rules. Again, these are much more related to the AI and machine learning compared to, for example, in week 21. And what we discussed or covered is usually considered as statistics. And so clustering and outline analysis is kind of coupled together. And clustering is to find groups and within your data set. And then anything that does not fit in any existing groups nicely, and that becomes the outlier. So these two kind of go together. And the association rules, you probably would have seen that already. Association rules, for example, the typical examples will be, people, when they go shopping in the supermarket, people buy beer. Also, quite often they would buy peanuts as well at the same time. So that's like a rule to say people buy beer or almost always buy peanuts, but it's not the other way around. Say people buy peanut doesn't necessarily always buy beer. And so the association rules is about finding these different, say, the kind of co-occurrence or correlations in your data. And so week 24 is when the last coursework will be due. So we're not going to have lectures or labs, just will be time to answer your questions about the last coursework. Okay. Again, so during the lecture, if you have any questions, I prefer you just to raise your hand and ask anytime, and you don't have to wait till the end, as we often run out of time, so you not even have time for you to ask questions at the end. And you can either raise your hand to ask or just type in something in the chat. I try to look at the chat as well as we go on with the lecture. Okay, yeah, and a little bit of information about the last coursework, and it will be the deadline will be the end of March, which is the end of the week 24, which is end of the term or the entire year or your master and for the taught part. The only thing I want to say is, I imagine there will be other coursework due at that time as well. And so I would recommend you to start as soon as you can. I mean, the coursework details is already, details is already available. It's okay. And it's not on the module page yet, but I will put it there and this week. And so you can have a look. And so start as early as you can and do a bit of planning, and because there will be other coursework due and around that time as well. Okay, and don't leave everything to the last week or last a few days. Okay, so in total there will be 25 marks, and just as all the other, just as the previous works. And then, as I already mentioned, the last week, which is week 24, I'll give you answer some questions. Or if you have already done the work, you can ask me. I can give you some feedback in terms of and what are the issues and how that can be further improved. Okay, and now I'm going to kind of give you an introduction of visual analytics, and almost some of these might overlap with the introduction we did at the beginning of the module, which is about visualization, but you probably don't really remember them anyway. So I think that will be a useful thing to do. Okay, so yeah, I'm going to start with what is visualization. So visualization is to present the information visually. And so sometimes people mention the picture is worth 1,000 words. And so here, for example, we have a visualization showing COVID. COVID situations in China. So you can see the map of China, and you can see where it has the most number of infections. And the chart here shows how the number of patients, assume is number of the patient, and changed over time. And so for example, for the chart, it's possible to see using, say, a spreadsheet just with numbers, but it's much harder to see the trend. And when you just look purely at the numbers. And whereas something like a map visualization involves map, and it's much difficult to describe it with, say, text or numbers only. I mean, you could potentially describe this data and using a spreadsheet. You can say for each different cities or states or they call it province in China, what are the number of patients? But again, it will be much harder to see the patterns like this, and what are the areas has the most highest number of infections, how they are spread relative to each other, etc., etc. Okay, and this is one of the definitions of visualization, which is a bit different from the one used in the book we covered in the first sector. So it says visualization is the process of presenting data in a form that allows rapid understanding of relationship and findings that are not necessarily evident from raw data. And so this is kind of more focusing on the utility. So the usefulness of visualization is to support rapid understanding of relationship and findings, and that are not read. So for example, if you just look at the numbers in a spreadsheet, these relationships and findings may be much less obvious, or you might miss them completely. Okay, and so visualization is usually an application, so something user need to interact with, so that requires a user interface. Is complete in the sense it's quite different from statistics or machine learning, where it can be a fully automated process. You write some code, and sometimes you just press a button, it will give you the results, and there's a very limited user interface if there's any, and there's very little user involvement in that, except and maybe in the first stage when they have to prepare the data and write the code. And so it provides a representation of the data. We're going to talk a bit more about that from the data. And it's usually interactive, and it doesn't have to be interactive. But say interactive is very important if you have, say, lots of data which you cannot show at the same time. So then in those cases, interactivity is very important. Okay, and so we kind of covered this already as well, just in terms of the type of data can be visualized, and then you can divide the visualizations into scientific validation and information validation. And so the scientific validation is for what's saying the physical data, which means the data itself already have a geometry or shape. And so for example, if you remember at the very beginning, we showed you some scans of human body, and human body already have a 3D shape. Those are the physical data. And the information validation is about presenting or showing abstract data. And so these are the data which does not have any particular shape or geometry. And for example, if you remember, we used lots of, say, we use a lot and the supermarket data or superstore data. You have the name of the products, the profit, the losses, categories, and these type of data which does not have particular shape, by natural you can define them. So these are called information validation. Okay, and so these are some examples of showing an abstract data. We would have seen this, and this is a scatter plot, and this is scatter plot matrix, which we can use. Some of you tried in the second coursework. And this is the map. So the map itself would have a shape, but the data you laid on top would be abstract. So this red thing, or maybe the bars, would represent certain attributes, which itself does not have particular shape. And then finally, the bubble chart. And so the bubble chart will be something, say, the size of the bubble and the color of the bubble would represent different information. Just give me a second. Let me move this one a little bit. No, I was cut it off. Okay, and so we also mentioned that the opposite or the other part of the validation is called scientific validation. These are the validations of more physical data, and you can see these things here. We have the scan of the human skull. These are the medical images, which already naturally have a shape or geometry. And there's some other simulations, for example, simulating and how the weather or the wind moves, etc., etc. Again, these things already have its own shapes or geometry. And also, if you remember, we mentioned before as well, and these are usually the case when 3D validation actually makes sense, because the data itself is 3D, so it makes sense to present them in 3D. Whereas for the abstract data, and 3D actually, in many cases, actually less effective compared to 2D validation. For example, you could potentially make the bubble chart 3D, make all the balls 3D, and not necessarily improving the validation itself. Okay, and then so the validation itself, the main task. So this is mostly relevant to information validation, where we have the abstract data. So the data itself does not have a visual form. It does not have a color or size, etc. And then the visualization, the main task, is to design a way that you transform or represent data visually. So we have this data, which usually is a spreadsheet of rows and columns, into some different charts. You can have a tree, have bar chart, other things. And this visualization should allow people to find something interesting from the data, which you cannot really see very easily. So as we said, so the design of this process needs to match the type of the data, whether it's a table or it's a temporal or it's a map, and then have to match the particular tasks you want to find answer to. And it's not about how colorful or fancy the visualization is. Then it can help user to find the data. And also we give you some kind of guidelines in terms of how to design these data, how to design these visualization, which depends on and how we add human and see visual patterns. Okay, and as example, this is the data in the raw form. So you have, I think this is, okay, I think this is the stock price, and you have the date. So this is 2010. So that will be the 5th of July, 2010. So that's the price for Shell, ExxonMobil, and BP. So these are oil companies. And this is some other measures. I don't know what this particular measure is. Word, I'm not sure what is DS, and oil and gas production, I assume. So that means maybe indication of total production of oil and gas. Okay, and so these are the raw data. Certainly all the information is already there, but it's actually not that easy to see the patterns, for example, and how the prices are changing for each different companies, and also whether there's any correlation between these different companies. For example, do their price go up and down in the same way or different ways? And so these are quite typical and visualizations, which you can just plot out these data, and then you can much easier to see the things we mentioned before. For example, if you look at this one, you can see maybe for the purple and green, and the general trend was going up all the way, and then kind of starting to going down closer to the end. And also the purple and green, these two companies, and their performance is quite closely related. So they are much closer together. Similar for the red and black ones, they are quite close together up onto maybe say here, and they started to have a quite big gap between them. But again, the general pattern in terms of going up and down still very similar. And so even, for example, here for the green and the purple, they are much higher than the red and blue, red and black, but then the trend is similar. So when they all going up, they are actually going up, this is going up. We have these like spikes here, go down, so on and so forth. Okay, and then so say maybe this kind of valuation is good to see what are the general trends over time, and whether say two stocks have similar movement patterns or not. But what they are not very good at is actually to tell you, okay, when might be a good time to invest, and what would the return will be like if you invest at a particular time. So obviously, in theory, you should always invest when the price is the lowest, but because you cannot really see the future, so no one knows when the price is the lowest. And so people just have to kind of sometimes take a chance and head into the market and decide, okay, I'm going to just buy something now. And so that's why some people make money and other people lose. And actually most of they called, I can't remember, the general public investors, usually they lose their money and actually quite a lot. Anyway, and that's a different thing. But this is kind of, so that kind of visualization does not really tells you when will be a good time to invest and how much return you would get. So this kind of visualization, what they are designed for. Okay, and so on the x-axis, and it shows that if you can read, it says time of purchase. So that means if you buy stock at that particular time, and the y-axis shows time of sales, and says, okay, if I buy the stock at that time, and if I sell at a particular year, and the color here indicates your profit. And I think the green color means making and profit, and the red color means make a loss. And then the darker the red means more loss, and the darker the green means you have more profit. And the first thing I want to mention is this one is not particularly good in the sense the choice of color, and usually I can't remember the numbers now, maybe 10% population is and red-green colorblind, which is most common color blindness. And so that means about 10% of the people will not be able to see your visualization as is intended to, because they can't tell the difference between these two colors. Okay, and so usually it is recommended to choose a much less common pair of a different pair of colors that's much less common to have people colorblind. For example, you can use orange and blue. I think that's a much safer color compared to red and green. Okay, anyway, and back to the visualization itself. And so you can see, for example, if you buy the stock in 1991 and sell it in the same year, and that's kind of color you get, which is kind of a neutral color, so somewhere in between the green and red. That means if you buy and sell at the same time, you don't really make money. Okay. But if you buy in 1991 but sell somewhere here between 1999 and 2001, you will make lots of money. You can see there's a dark green here. And then so on and so forth, and samely for 1992. But in general, the trend will be, say, between 1999 and 2001, these are the good times to sell, and probably the price is the highest. And similarly, if you look at this side, if you buy stocks in 1999 and 2001, you are likely to make a heavy loss, and that's the time when the price is actually very high. And as the time goes on, the price is likely to drop, then you have making big loss. So for example, if you're buying 99 and it will be here, selling the same year is okay. In 2000 and 2001, you're still making some money, but starting from 2002 and 2003, you're going to start losing money and losing more and more money afterwards. Okay, and so this is a kind of a particular way, and which just to show you, okay, if you want to understand when it will be a good time to invest, this may be a better visualization compared to this one. Okay, then so in this visualization, previously we're only using half of the square, and so we can use the other half and to put other information, and so you can put something else you want to compare to. And for example, if you look at this one first, you can look. So these are two potentially, yeah, I think it's two different stocks, and you can see for this one, it has a much larger kind of area which you make profit compared to this one. It's a bit smaller. And here you can actually compare to some other things, which is not stock. For example, you can choose to compare with the bond, which has much more kind of stable, much less volatile. There's very little change in the price. and it's almost always guaranteed, but the return is much lower. So you can see the color of green is much lighter. And you can do this for example, for many, many different stocks. Let's say each of these little blocks is a stock, square is stock, and these are different ones. I don't know, maybe more than 100 of these. Okay, let me see how we are doing. Okay, oh, lost it again. Okay, so usually, the data set is quite large. We already explained and expand and discuss this. So that large and could be because it's too big, the computer cannot process it, or could be too big, it's not enough and space to display all the information on the screen, or it can be too big. And as a human, we cannot understand them properly, even though the information is presented. And usually the last one, and how much information we as human can understand at the same time, and is the most limiting factor. Okay, and then to support this, and we have to design the visualizations which would fit how we see things. So there's certain patterns we are much easier to see. Okay, and so in terms of presenting this information, and one of the goal is to make the large data set coherent in terms of present a large amount of information compactly. And this actually means sometimes you hide some of the details, just providing an abstract or aggregated overview. And that might be more useful than just to show every single items in a very large collection. And present information from different viewpoints, so allow you to kind of examine data from different angles. For example, previously when we talk about the stock data, we saw both as a timeline or as a matrix. So these are two different viewpoints. That's for different type of analysis. And then present information at several levels of details. So this is related to the first one. So when we have lots of information, we might want to only present a kind of simplified or aggregated view first. And maybe one of the examples that we mentioned before is like the Google map. And when you start with like a word map, you don't show every single street in the world. That's just not possible. You might just show the continents and name the continents, not even all the countries. And then as you zoom in, you start to see the countries and then cities, and to the very fine details, you can see different streets and their names. And then, so there are many different types of visual analysis, and one thing quite common is to support visual comparisons. And so, for example, here, we try to compare different stocks and their performance. There's other type of comparison. And finally, to tell a story about data. And so this is probably the hardest thing to do. And you probably would find some things interesting about data first and different findings. And before, sometimes these findings actually connect together, and you can actually tell a story about the data. Okay, and so in terms of the findings, it can be about the structure of the data, some patterns in the data, or anomalies in data, so something which does not fit the overall trend. So all these are different types of valid and useful findings. And to help you explore and analysis large data set, that's the general goal. And sometimes just could be the data set is very complex, doesn't have to be very big. And then finally, to communicate the information to people. And so if you remember in terms of the goal of analysis, so there's discover, but also there's a goal of present. So you have some analysis result, you want to show other people what the result is. And probably more important, how you get to the conclusions or the results. And you need to communicate the information to the people. And for these needs or requirements, and then validation can be quite useful. Okay, and then also need to be careful, and validation can distort the truth. Just as, I guess, any data depends on how you process or present it, and it can present it not maybe the most truthful representation of what the reality is. Okay, and so here we're showing a scatter plot, and so we are showing 4 scatter plots, and they are using the car data set we used at the beginning. And so we pick the 2 attributes, the city MPG and the retail price. So x-axis is city MPG and retail price is the y-axis, and each dot is a car. Okay, and so just depends. So the only thing different is how do we draw the x and y, and the scales we used for the x and y scales. And so for example here, so you have the large scales in both x and y. So this basically represents a very large range of values, and same for the price. And as a result, all the data seems to be grouped together here. And it says, I think this means, and the large scale in y. I think maybe this is the opposite. This is the large scales in the x-axis. So for example, you change the scales of one of them, you can see now the retail price only represents a quite small range. And then you can see the price differences of distribution of these cars and how they are different. They're actually not tightly grouped together. But in terms of the city MPG, which represents how fuel efficient they are, they're still kind of grouped together because the x-axis is still quite big. And so this is the opposite, where you have a very big range of retail price, but very small range of city MPG, and you start to seeing the distribution, how these cars, how fuel efficient and these different cars are. And finally, you have a small scale for both, and you can see the actual distribution of these cars in terms of price and fuel efficiency. And so in some sense, so this, and this one, and this one, they don't really give you a very accurate information about how these cars distributed, and it's just purely because how the x and y scales are set. This is probably the much realistic information about how things, or more useful information about the distribution in terms of price and fuel cost, fuel efficiency. Okay, and so when we design the evaluations, and so the important things we need to consider is to make sure, and so the main task is to convert abstract information, the numbers, for example, and price and MPG, to a visual representation. And we want to preserve the underlying meaning. So this is something we didn't really discuss too much before, to make sure, and the visualization actually does not distort the data, like these rays we've seen before, and then providing some new insights. So something people cannot see directly just by looking at the raw numbers. And so this is one of the statements supposedly to be said by Einstein. And so he was saying the best way will be to combine computer and human together. And they both have their advantages or strengths and weakness. The computer are fast and accurate, but they are stupid in the sense they don't really have their own thinking, they don't have creativity, and so on and so forth. But humans, on the other side, their weakness is are slow and inaccurate compared to the computer, but are brilliant. So we have, say, creativity, can come up with new ideas or designs, and then together or achieve the best results. And so far, and in terms of validation, we much more focus on the human side. And for this part, we're going to do a bit more on the computer side as well, and to see how best we can combine the two together. And so this is where the visual analytics comes in, and its emphasis on a stronger integration or work together with data analytics. So not just thinking about validation. And so visual analytics is the science of analytical reasoning facilitated by the visual interface. So you use visual interface, which is data validation, to support analytical reasoning. So where this is data analysis would be doing, would be happening. Okay. And so this is a diagram to explain what the visual analytics might look like. And so you have the data, you can visualize it by presenting it visually, and then human might get some new insight from the visualization. Also, you can do analysis using machine learning, statistics, and you might have found some other different findings. And these two influence each other. So what you found from the visualization might help you to adjust your analysis. For example, and by a look at visualization, you realize there's lots of data which are missing or actually not correct, doesn't match, does not make any sense. That might allows you to go back to data transformation or change your models, either to handle these, say, inaccurate or missing data, or just ignore them differently. And similarly, based on what model looks and results, you can also adjust your visual design. And both of the validation and model will give you some knowledge about the data set. So I would say, and the validation we talked about so far is mostly about the top pass. And so you come from the data, you do some transformation, visualization, and hopefully to find some knowledge. And now we want to including the bottom pass as well, from data and model and to knowledge, and the kind of integration between the validation and model part. Okay, and so this is a kind of something related but more generic, but also more focused on the data analysis part, and called the KDD process model, and proposed in 1996. It's kind of like a more abstracted, high-level way of describing usually what are the different steps involved in data analysis or knowledge discovery, and what is the KDD stands for. And so you have data, you have focusing, I think it stands for focusing on certain problems or certain parts of data, and you do your pre-processing, so this including reformatting the data, handling missing data, etc. And you do transformation, so they can be used for your particular data analysis method. Here is called data mining, so this could be statistics, could be machine learning, could be any other methods. And this is presented visually, or this is the results of your data mining. It can be presented visually or not. And finally, the user would evaluate the results and lead to some knowledge. And also, it's important to know this is an iterative and interactive process. So it doesn't just go from left to right. And depends, for example, for what you found, your result, you might go back to focus on different part of the data, or do a pre-processing differently, or do the transformation differently. And again, it depends on the results, you might go back to certain parts. So that's the back and forth, iterative and interactive process, in the sense the users will be involved in each step to change or decide what to do. Okay, and so this is the example of this process. And the first part is to understand the application. So this is almost like the, if you remember the what, how, and why model. So this is the why part. Why do you want to analyze the data? So in this case, we want to set a new phone call rate. Okay, so basically, the phone call rate here means how much would you charge a person to make a phone call? How do you charge it? So do you charge it, say, a connection fee, and then every 30 seconds, or you don't charge a connection fee, but you and also you charge by minutes instead of seconds, so on and so forth. So this comes from the application side, or the application domain, and what the analysis wants to achieve. And this one converts that to the analysis side. So it becomes an abstract from the application domain. So what it do is want to do custom segmentation, and essentially this is kind of grouping of customers. So they have different type of customers. Maybe each segmentation or customer group would have different way of charging them. Okay, and once that's decided, you need to get the data. You need to get data from the current. So let's say this is a telephone company, so they'll have data about the cost or the phone bills for people every month. And this is the less, how do I say, less kind of data analysis problems, more about data management in terms of database, whether you use file systems or database systems, and then selection of the data. So this is more the kind of the actual, or also part of the focusing in terms of what part of the data I'll be focusing on. And if you're a large, and for example, you're a large telephone company like a British Telecom, you have so much data of millions of customers over, I don't know, decades. And you can't really, or at least it's not practical or efficient to start with all the data at the very beginning. So you might select a subset of the data from a particular period. That's the focusing. And then you need to integrate data from different sources. Usually you don't have all the data in one record. For example, you have a table which including the user information, their name, their address, how long they have been with the company, and you have the table which actually have the detail of the phone call and the costing of the bill for each month. So how many calls they have made, how much they have to pay, how much of them are, let's say, long distance call, international calls, and so on and so forth. And obviously you need to do any check-ins to ensure the data is correct. And even for telephone companies, and the data is not always correct. And for example, you want to maybe duplicate the records and make sure it's actually consistent. For example, I don't know, say it's unrealistic that people can make more than 24 hours of phone call a day, for example. There must be something not quite right. Even the people making, say, 10 hours of phone call a day, that might be quite rare or a little bit kind of, so must be something happens. People spend so much time on the phone a day. Okay, and so these are the pre-processing steps. Next one will be the transformation. So one of the common tasks in transformation is to discretization of numeric attributes. And then that depends on the type of algorithm you want to apply. And some of them cannot handle continuous values. And for example, how long the amount of time people spend calling each month is a numerical value. So it can be, say, 1 hour, 20 minutes, and 30 seconds. And can be, so that in theory is a continuous value, but that may be too much for the algorithm itself. You have to discretize it. For example, you will say, okay, I only consider the resolution up to a minute. So I ignore all the other values in between 1 hour, 1 minute, and 1 hour, 2 minutes. So these are only 2 values. Okay. And then you also need to select the attributes or the information you want to feed or use in your analysis. So there's lots of information, for example, about the customer. You have the customer name, address, maybe gender, or maybe even age as well. But for example, and if you want to set the rate or do customer group and grouping of the customers, maybe the name of the customer is not particularly relevant. Whereas, for example, the age or maybe gender is much more relevant. And so you need to select what information to use. And this can be done either manually or automatically. So in the automatic sense, some algorithms will automatically try to select what information to include. And sometimes sometimes the algorithm itself is actually not very smart. It's just trying all different combinations. Okay, I'll pick the first attribute only, and second attribute only, and now third attribute only. And then after I tried all those, I tried first and second attributes together, and so on and so forth to see if I get good results. So not always very efficient or give you the good results. Okay, and then so now we comes to the data mining stage, and it's actually, I'm not going to go through the definition here, but sometimes the mining is kind of used interchangeably or means the same thing as statistics or machine learning. And so if people talk about data mining, you can either treat it as statistics or machine learning. There's not that much, there's all the same, there's a very large overlap between these different concepts. But much more useful is different tasks. You can see these are similar ones that you would use in machine learning. So the first one is clustering, is to find the groups. And the next one is classification, to decide and which group and the items is in, and usually has a label. And finally have the association rules. And if A and B both exist, then C exists. So that's association rules. So we'll cover all of these later and to some extent in the next 3 lectures. Okay, and so there's some type of these analysis and using descriptive methods. And so these are the more related to kind of statistics. And the other type of methods is the predictive. And so you want to predict what the value is, something you don't know. And this could be predicting something that will happen in the future, and could just be producing some missing data from your data collections. And for example, you're missing the age for a particular customer in your customer database. And you might be able to predict what the age is based on other information you have. And for example, you have 10 other customers with very similar demographic information compared to this one. So you might use their age to replace the person. And also, and visualization also can be treated as one of the data mining tasks. But if you talk to a data mining person, they might not think this is as a data mining method. Okay. And so KDD stands for knowledge discovery in databases. So knowledge discovery in databases. Okay, so that's a particularly research community or research area, which is a bit different or traditionally separate from VA, which stands for visual analytics. But I would say they have more and more overlaps over the times now. And partly because the process they go through, either as data analysis or visual analytics, are quite similar. So these are all the ones that will be involved. Whereas even the pipelines or the process looks a little bit different. The KDD is more flat or linear, whereas the visual analytics looks more interactive and iterative. Okay, and so one of the main tasks you will do for this part is to construct a workflow that will allow you to complete analysis task. I mean, you kind of do that already. For example, when you create a validation using Altair, and you would create say a Python notebook, and you have steps and different bits of code, and that itself that can be considered as a workflow. And so each cell with code can be considered as a steps in the workflow, and two cells are connected if a step depends on the step before it, or a cell depends on the result, which is computed in the cell before. But that's not always is linear, because some of the cells does not really depends on the cell before it, and some of the cell depends on the several cells before it. Okay, and before we get into details, and in general, the workflow, including first reading the data, do some data pre-processing, and then do some analysis, could be training a machine learning model, and finally do the test on the model, just to see how good the result is. Okay, and then this can be, okay, and I have a question about the coursework. And the question says the last coursework will be in Python. The answer is no. The coursework will be in this software called 9. And in that, you can build a workflow which looks like this. And all these are pre-made blocks, and you can just drag and connect them. You need to do some settings, and then it runs, and the results will come out from this end. And so you can roughly see you can kind of get the name, get the function of the blocks from the name. So this is read data from a table, and it's partition the table into separate parts. And this do some coloring by the class. So maybe it depends on different type of products. You have different colors. And then this gives you the decision trees, which come up with rules, say what kind of, how do you predict, for example, how do you predict which product type it would be in? And this gives you the model after the training, and this do the testing to see if how well the decision tree performs, how accurate the prediction of the classification is. Okay, and so as I said, I'm going to using something called 9. Let me see if we have any. Okay, I don't really have any good pictures here, so but it's something it's a free. and you can download and install on your computer. I'm just running it here on my computer. That's what it looks like. Okay, I'm still loading. Yeah, so that's what KNIME looks like. So, for example, I'm opening up a simple classifier. Okay, this is a simple workflow. You have these boxes, and you can connect them together. You add these to your workflow and then connect them together. And then eventually you run, and it will start from here to read data and all the ways goes through here. And you have the decision tree, and you can either test it or say and visualize the result, for example. Okay, and so that's the link to download the KNIME, and you can also just Google KNIME and you will find it. As I already said, and so this is kind of, we'll talk more about this, but these are the blocks, preview blocks in KNIME, and you need to add them to kind of your workspace, and you need to add the connections. And for example, each of these, you need to change some settings as well. For example, for file reader, you need to tell it where it can find the actual data file, and so on and so forth. Okay, and once you created a workflow, and you can click run, and it will just go through the entire workflow. Okay, and so this is more specific about KNIME, and you can see these little kind of dots or colored dots below. It indicates different states. The red one means inactive and not configured. So when you first add a node to a workflow or your workspace, it might look red. And the yellow one means you configured, you change the setting. For example, you tell it where it can find the file, it becomes yellow. And finally, you run it and it's successful, they have a green. And if we run it, it has an error, you would have something like this. I think these are quite intuitive. We should be able to figure out. Okay, and so that's a link for the introduction video. And if you go to KNIME website, there's also other informations about how to use it. Okay, and so this again is another example. So this one is a video which shows you how to use KNIME.
ETL nodes within KNIME, although I would say maybe you're not using the application at its fullest, which is what the KNIME Analytics platform provides.
Okay, so this is where it starts.
Webinar. I'm here with Cynthia Padilla, and she's.
Okay, and then so there's another resource, which is this one, and that's the book, and cover similar things. So this is only I think the first part of the book. It's not the entire book, but covers everything we need to know, and in terms of for the module, and so it tells you how to use KNIME. So these are the two things that's useful to know, and if you want, and how do I go back to my slide? Okay, and so that's it. So the last thing I want to say is we'll have a lab later today. So do download and install KNIME before the lab session. Because I mean, you could do that during the lab, but KNIME itself is quite big and it will take a while to download and install. And so to save us a bit of time if you could install that beforehand. Okay, and I think that's it.